In this video, I'm going to explain how you can modify the Crank-Nicholson together with Thomas method to solve the first problem in the problem set 7. This is the script for Crank-Nicholson, and on the bottom of it, we have the script for Thomas method, which is a function called by Crank-Nicholson script. So let's go over the Crank-Nicholson script more quick. The first part, this is just a declaration. We have del x del t. Ratio is del x squared over del t. N is number of x points. This is exactly equal to n over the x values, so x1 to xn. The n, which is number of intermediate points, is exactly equal to num x steps. Maximum time is the maximum time that you're going to go over. Time is the current time. V's and u's are exactly the same as v's and u's over here. So u's on the left, unknown. V's are known to the right. These three lines clear the spreadsheet after any run. Delta t is read from the spreadsheet. Del x is also read from the spreadsheet, so these are the inputs. You're going to calculate ratio as del x squared over del t. Maximum time, again, you're going to read it from spreadsheet. N, which is number of intermediate points, can be calculated as 1 divided by del x minus 1. The reason is when you divide 1, which is the maximum x values in this case, if you divide 1 by del x, you get actually n plus 1 points. But number of intermediate points is n. So to get n, you have to divide 1 by del x and then subtract 1 from it, because 1 divided by del x is n minus 1. Minus 1 becomes n. I hope that is clear. Next, we set the initial time to equal to 0. Re-dimensionalize v vector and u vector. Note that these go from 1 to n plus 2, and the reason is, look at this figure, you see that we have n intermediate points from un, from u1 to un. We have two boundary points, u0 and un plus 1. But the important point is, in VBA, we cannot have 0 index. So our index in VBA starts from 1, meaning that u1 in this figure becomes u1 in VBA. u1 in this figure becomes u2 in VBA. u2 in this figure becomes u3 in VBA, and so forth all the way to un plus 1. So un plus 1 is un plus 2 in VBA. And that's why we have n plus 2 elements here. And similar case with u's and v's. Now when you get to C, D, E, B, these are the coefficients of the Thomas method. Basically, these are the coefficients in this matrix. And we note that the coefficients here actually go from 1 to n. D's go from 1 to n. E's go from 1 to, well, n minus 1. We can have n elements where we can not use the last element. C's go from 1 to n, but we can not use the C1. So we can have 3 arrays for C, D, E's with n elements. Right side B's are again from 1 to n, and that's why we have 1 to n for C, D, E, B. Now X is the solution of the Thomas method, which is actually the solution to the system. Now I have u's here, but when you solve this Thomas method, you get actually x values here. Next, when we go over the script in Crank-Nicholson method, we're going to read the initial values as I have on this comment line. So these are the input from the spreadsheet. We're going to assign the initial values to v's. Again, v's are on the right side, these are known, and we're going to calculate the u's. So before calculating the u's, we have to calculate the coefficients of Thomas matrix equation. The coefficients were C, D, E, and B. Now, C's are minus 1, B's are minus 1. If you look at our equations before, you see that C's exactly equal minus 1 here. E's are minus 1 here, and then these, or D values, are 2 times 1 plus ratio. This is ratio del x squared over del t. And that's why we have d equal 2 times 1 plus ratio. Now, when we get to b values, it becomes a bit tricky. Now, in this case, let's look at b1. b1 is v0 minus 2 times 1 minus ratio times v1 plus v2. But the thing is, in VBA, we cannot have v0. Again, there is no zero index. We have to increment all indices by 1 in VBA. So if I want to write this line in VBA, that would be v1 minus 2 times 1 minus ratio v2 plus v3. Okay, I again incremented indices by 1. So let's look at here. When j is 2, the first index, then you get b1 equals v1 minus 2 times 1 minus ratio v2 plus v3. And this is exactly equal to this line, v0 minus 2 times 1 minus ratio v1 plus v2. Okay, so this is exactly consistent with the note. Now, once this loop is over, we calculate all the C, D, E, B, but we need to modify C and D. How we can modify this? We refer to what we derived in the last video. We proved that the new C in the Thomas method needs to be Cn plus 1/3, and new D needs to be Dn minus 4/3. So all you need is, after this loop, you have to have 2 lines to correct Cn and Dn only, not all other C's and D's, just Cn and Dn. In other words, Cn is equal to Cn plus 1/3, Dn is equal to Dn minus 4/3. Okay, so you're going to have 2 more lines after this loop, not inside the loop, outside the loop. This line, also needs to be changed. We don't need this line anymore, because if you look at the example is on the right side of the boundary, we have the value equal to 1, and that's why the b coefficients have changed here. Particularly the last one is b plus 1. So we have to get rid of this line in our script to solve the first problem. Okay, so this line is not needed anymore. This is where we have 1 on the right side of the boundary. Now, since we don't have 1 on the right side of the boundary, the right side boundary is derivative of t with respect to x equal to 0, so we don't need this line anymore. Now we're going to call Thomas method. After we call it, then x values are calculated. Now we're going to assign the x values to u's, right? So these are the solution to the system. Note that x values go from 1 to n. Now x1 is corresponding to u2, right? So let's look at this figure again. u1 in this figure becomes u2 in the script. So if this is x1 value from the Thomas method, that needs to be assigned to u2. x2 goes to u3, x3 goes to u4, and that is again because we don't have zero index in VBA. So these are the assignment. Now you need also to modify this line. u1 now is equal to 0 because the initial condition is 0, so you have to change this line as well in your solution. The right side has to be 0. Another line that needs to be changed is actually this line. This is saying the un plus 2 is equal to vn plus 2. Now in our case, un plus 2, which is the last u value, comes from the boundary condition. So we had this boundary condition before, and this is right here. Last u is equal to 4/3 of un minus 1/3 of un minus 1. Again, you have to increment the indices by 1 because in VBA, indices starts from 1. So then this becomes u n plus 2 is equal to 4/3 u n plus 1 minus 1/3 u n. And that's what you have to implement instead of this line. So you need to get rid of this and implement that boundary condition. That is going to give you un plus 2. This is all you need to run the script. The rest of the script is to writing the solution use to the Excel sheet and changing the okay, I guess I skipped over this. Then assign U's to V's and be ready for the next cycle. In the next cycle, you have to have V values, and the V values of the next cycle are exactly equal to U's of the current cycle. That's why we assign U's to V's before finishing the while loop. After while loop is over, basically you're going to go, that means you've gone over all the time points and you've written all of the U's onto a spreadsheet right here before actually ending the while loop. The rest are just modifying the font size and font name, and these are to fixing the decimal digits of all the numbers in the spreadsheet to 2 decimal points. I hope this is clear and you can do the first problem of homework 7. Thanks a lot for watching.